As you can imagine, this is the easiest problem that you're gonna find. Nevertheless, it's a problem. So, well, we need to find the linear speed of a point that has like, well, different points that are like at different distances at the radius, and they are rotating at different frequencies. Okay, so the first one, we have revolutions over minute. We need to turn it into radians over second. Okay, this thing applies for both of these guys. So we're gonna start with part A, and I'm gonna say 500 revolutions over a minute. I need to transform it into radians per second. This thing is gonna be well, I did the math already, so this is actually gonna be 50 thirds of pi radians over second, or that thing is actually equal to 52.35 radians over second. Okay, so with this formula, we know that linear speed is going to be the velocity times the radius times omega. From here, we can just say that the velocity is going to be the radius, it's 2.4 centimeters. That's going to be 2.4 times 52.35, these parentheses here, and that actually is gonna be let me write it down here, 40 pi, or what's the same, 125.66, and this is gonna be meters over second and meters over second. Once again, you can leave it in terms of pi or write it just like the whole number. Both of them are valid. Okay, here's the first one. I know I screwed it here. It's centimeters per second. There you go. For the second one, let's start working. Let's keep on the woodwork, and it's pretty much the same thing. Have 200. That's going to be revolutions over minute, and I'm going to transform it into radians per second. That is 20 thirds of pi radians over second. Once again, I already did the math. It's very easy. Do it on your own. And it's actually 20.94 radians over second. Now, from here, we just have to do exactly the same procedure that we're going to do 6 centimeters. From this formula, once again, well, velocity equals radius times the angular velocity. And we have a radius of 6 centimeters times, I don't know, 20 thirds of pi. And that's going to give me just like 40 pi radians over second. No, meters, sorry. Let me just erase it. There you go. Meters over second. And that's actually equal to 125.66 meters over second. Okay, so all of this are valid answers.